Example 4. A baseball. A ball is hit on a north 17 degrees west angle to the left center field wall, about 382 feet away. So let's draw that first. A ball is hit on an angle of north, so this is, we're going to assume north is straight ahead like this, to 17 to the west, which maybe it might be something like that. So, and I'm going to put a dotted line on here so we can see the angle from the north. We're saying that this is 17 degrees to the west. So this is our north, and this is our west over here. This would be our east, and this is our south. Okay, and this is 382 feet away. The red line is 382 feet. The player must make a throw to third base. So the player is going to pick up the ball and throw it to third. I'll change colors here so we can see what's happening. So the player picks it up and throws it to third base right there. Given that the infield diamond, this right here, is made up of a square with each base 90 feet apart, how far of a throw must the player make to reach third base? Round to the nearest foot. And so to complete our triangle here, I'll get a piece here that's got color on it. You're looking at this triangle like that. We're going to try to solve for this triangle. We want to know how far of a throw the player must make to throw the guy out at third base, basically, is what's being asked. So this is the triangle we're looking at. And to give it more room, I'm going to redraw it over here. I'll just copy it. And so I've copied mine right here. And now let's fill in the data. What we know is this. This base is 45 degrees from this dotted black line. We know that is 17 degrees to there. So I can find this one by saying 45 minus 17. So I'm going to come over here and I'll clear my calculator. And so I'm going to first say that this is 45 minus 17. I'll explain how I got that here in a second. The way I got this is because each base is 90 degrees, and so this is 90 all the way across, but this is cutting it in half. So this right here is this one, and this angle will add up to equal 45 degrees. I started to say complementary, but that would mean they would add up to 90. The truth is these two add up to 45. So I took that 17 away from 45, and I got 28. That means 28 degrees goes right there. That's really ugly. So I'm going to try that again, 28 degrees. That's what goes there. We know this is 382 feet here. We don't know this distance. That's what we're looking for. That's our unknown. But we know this is 90 feet because each base is 90 feet apart. So that's what that length is. Now, how can we solve this? Well, let's check to see if we can find any other angles. As I look at this, I can see I don't have this angle. I know that this part's 90 degrees, but I have no idea what this angle is on this side. I can't just say it's a straight up 45 because there's nothing, this isn't parallel to this one, so I can't really do it that way. So as I look back, it doesn't look like I can get any other angles, so I can't use law of sines, but what I can use is law of cosines. And also, I need to eliminate psi y cos x tangent as y over x because I don't have a right angle. So I'm going to go to my formula chart. I'm going to look at the law of cosines. This works anytime you have three pieces, an A, a B, and a C value. And so as I look at this, I have an angle, and we could call this, I'll give it a capital A here. I have a capital A. I don't have the length A, but I do, nor do I have capital B, but I do have a lowercase b. I don't have capital C, but I do have lowercase c. So law of cosines works anytime you have three pieces, three different letters to work with. Or said another way, I don't have a completed set. So I'm going to use law of cosines, which simply states that a squared equals b squared plus c squared minus 2bc times the cosine of a. We're looking for a. A is going to be in the place of x here from our formula. So I'll say that x squared is going to equal, my b is 382, my c is 90, and so I'll substitute this a second time, 382 and 90, and our cosine angle is 28 degrees. Now that's what I'm going to be typing in the calculator, And to solve it, just to get x by itself, I'm going to take the square root. Now, usually we do a plus or minus, but because this is a real-world application, we're only interested in the positive value. I'm not going to do the plus or minus. I'm just going to see what the positive is. So I'll have 382 squared plus 90 squared minus 2 times 382 times 90 times the cosine of 28 degrees. And this tells me my throw has got to be 305.4 feet. And it says round to the nearest foot, so I'll say that x is approximately, this throw is approximately 305 feet. And this here would be your answer. Now let's try the second one. It says flight. An airplane flies southwest. So I'm going to start us off kind of at the origin here, and it's going to fly southwest for 620 miles. So southwest is, southeast. So it's going southeast, which would be this direction, because the east is to the right. So this would be north. Let me label my axis. East, south, and west. So anytime it says southeast, it means split in the middle for 620 miles. And it's going to turn west 15 south. So it's going to turn west 15 to the south. It's going to turn this direction. So I'll put the 620 here so it doesn't mess up my triangle. The plane's going to turn west 15 degrees to the south and fly for 125 or so. So this right here, if you drew a dotted line, would go down 15 degrees. Now, what are the magnitude direction of the airplane from its starting point? Basically, what we're trying to find is what would be its angle and distance from the starting point. What about this blue line? That's what we're looking to solve here. So let's start off with some things we know. Since this was flying southeast, this angle had to be 45 degrees because southeast is right in the middle. Now, if that's 45, then over here, this would also be 45. That's what that means. This would also be 45. Now, we know this is 15, so 45 and 15 would combine and give us 60 degrees. So I'm going to copy this triangle like I did last time, and now I'm going to fill in this angle with 60 degrees here. And one thing I did not fill in on this is 125 miles. So we can do that here and here. Now again, this is going to be a law of cosines because I don't have a completed set. However, what we do have are 3 separate pieces. If I called this angle A, I have angle A. I do not have side length A. I'm going to be looking for that. But I do have, if this is angle B, I have side length B. And if this is angle C, I do have side length C. So I could use law of cosines to solve this. Now, there's something else I could use to solve it, and it's going to be vectors. And we're going to do that here. I'll do it with vectors first this time. This vector, since it's going southeast, it's going 45 degrees downward. So I'm going to replace this vector with 620. That's its h. And the angle is going to be negative 45 degrees, because you switch it and go for the math in the calculator, you would go from the x-axis. Now over here, this one turns, and it said it's going west 17 degrees south. So if you thought about this from the origin, west 15 degrees south, would be 15 more than 180. So this one is going to be 125, comma, angle, it's 15 degrees past the x-axis, and that which is 180 on the left. So that would be 195 degrees. Now I could add these together and solve vectors to get my answer. So I'll go vector here, and we'll have 620, comma, and now we put the angle. Now don't forget, you got to go to the book and go to under number 4. You have to choose the angle right there. And the first one was negative 45 degrees south. That means that it's going negative, which means the angle is going downward from the x-axis. Now we're going to add that to what the plane do second. Well, it rotated and went 125 miles on the angle of 195 degrees. Whoops. Let's try this again. 195 degrees. Now, whenever I press enter, this gives me the x and the y. This means it goes 317.6 miles east and then negative 470.7 miles south. That's basically what it's saying. But if I wanted to convert it to find this length, what I would do is change it to polar. So I go menu, 7C, which is vector, and then choose 4, convert to polar. Hit enter. This tells me my distance. The magnitude is 567. I'm going to round to the nearest tenth. 567.9 miles. That's how far the plane needs to travel. On this blue line, hit it straight there. And the direction, since it's negative, that means going from the east down. The direction, so again, the negative just means it's going downward from the east. It would be east. I'll round this to 56 degrees. East 56 degrees to the south. Or if you want to start from the south, you would take 90 and subtract that 56. And you would say it's south 34 degrees east. This would be my answer here. Now, as I was mentioning a second ago, I could solve this using law of cosines, just like I did the previous problem. But this is probably an easier way of doing it with vectors. So let me go back over here and show you how on this one we use law of cosines. Let's see how we could do it with vectors. This ball was hitting 17 degrees past north. Well, north represents 90 degrees. So it traveled 382 feet at an angle of 17 plus 90, which is 107 degrees. And you would add that to the this distance here. Now let's be careful because you have to always have them connect tip to tail. So this distance is 90 feet, and its angle, which normally we would say this is 45 degrees past from here to there, would be 90 plus 45 degrees. So that would be 135 degrees. Now here's the problem though. That would be if the angle was pointing this way. Since it's going the opposite direction, we need to go back and change this to a negative 90. If we do this, we should get the same values we just got over here. Let's try it out. So I'm going to come to my calculator, and we'll get the brackets here. And we're going to have 382, comma, and then choose the angle. So book, angle, the first one was 107 degrees. And we're going to add that. The second vector was 90 feet, but because I'm switching the direction and making it come this way, I want to say it's negative 90. So anytime you want to switch direction, you just make the hypotenuse negative. And then I say angle, and this would be 135 degrees. 135 degrees. So again, I press enter. This is telling me it's from here it's left and up. Press menu, 7C, 4. And we find out here, just like we said before, the throw needs to be 305 feet. The angle upon which it happens from over here, that's where this 99 comes from, but we'd have to convert that, because it's no longer accurate because we would be starting from here at the origin rather than over here. That's why the angle looks funny.